So in this video, we're going to talk about how do we differentiate whether a compound is purely ionic, whether it's purely covalent, or actually do we have a mixture of the both? And to kind of of both, and to kind of answer the question, we actually need to actually know the periodic table. Now, with the exception of hydrogen, which is actually a gas, usually in the S block, most of these are what we call your metals. No, there are different types of metals, alkali metals and alkali earth metals. And we can talk about that in a different video. But the idea here is that with the exception of hydrogen, everything in this S block is actually metal. Now, over on the right hand side, we also have the transition element block, and most of these are actually metals as well. So most of these are actually metals. They're just transition metals. But again, most of those are metals. Now, on the right hand side of the P block, it's a little bit cumbersome, but for general chemistry or even organic chemistry, uh, most of the elements that I'm circling right now are going to be actually non-metals. And so we're not going to get into stuff like tin. Tin is a metal, or bismuth, etc. Those are for grad school, but on the undergraduate level, whether it's organic chemistry or general chemistry, you should suspect that stuff like chlorine, sulfur, phosphorus, argon, these are non-metals. And so we're going to stop about there for our non-metals. Bromine is also a non-metal, krypton, right? The reason why you need to know this is because I want you to keep something in mind, that if you have some sort of metal within your molecular formula, then we know it has to be partially ionic. Now, if it's completely ionic, that means that there is no non-metals, right? So let me kind of summarize that. So, for example, if we need an ionic bond, so an ionic bond, right, must include a metal, right? So for your level right now, whether it's general chemistry or organic chemistry, you must keep in your mind that for an ionic bond, it must include a metal. For a non-ionic bond, or what we call a covalent bonds are usually between non-metals, right? So we could say these are bonds between non-metals, right? So on this side of the periodic table where we have our non-metals, right? Anything with that included would be our non-metals. Now remember that we said that hydrogen was an exception and that it is actually a non-metal, even though it's on the side where we classify where we have most of our metal or metals are at. Right. So with that with that in mind, let's do some identification. What if I give you sodium chloride, or what if your professor gave you NaCl on the test? Would it be a metal or non-metal? Or would it be an ionic bond mixture, or would it be purely covalent? Well, in this case, I know that sodium is actually a metal, right? It's in right. Sodium is right here, and but chlorine is actually a non-metal. So chlorine is actually a non-metal, and so you would think that uh, sodium chloride is actually a mixture of covalent and ionic, but sodium chloride is an exception. I want you to keep in mind that sodium chloride is actually purely an ionic bond, right? And the idea is that we have sodium that gives us a plus charge and chlorine that gives us a negative charge. And the idea is that we have charged um, elements in our molecular formula, and it's not really a bond, right? So in fact, sodium chloride is purely ionic. What about, and I'm going to show you a difference because sodium chloride is really weird, and you would think it would be a mixture of both, but it's not really a bond. It's just charges like a broken down right here. Convert sodium chloride to CH3Li. Here we actually have carbon being bonded to three hydrogens, right? And then we have a lithium outside. Now, if you look at this, carbon is on the nonmetal side. Hydrogen, remember, even though it's on the metal side, it is a nonmetal, so that's an exception, like we said before. So that is covalent. So this CH3 by itself is covalent. The lithium, however, is actually a metal, and it's a metal, so it's over here. Lithium is right here, and so this is actually a mixture. Now you may be confused, and you might be saying to yourself, well, sodium chloride has sodium, which is a metal, and chlorine, which is a nonmetal, but it's purely ionic, while, you know, in this case, methyl lithium or CH3 lithium has nonmetals, which is carbon and hydrogen, but it has metals, but it's a mixture. So what is the difference? The difference here is that carbon is there's actually a bond between the three hydrogens and lithium. Whereas in sodium chloride, even though chlorine is a non-metal, there is actually no bonds. It's actually being held together by charges, right? In or CH3 lithium formula, there are no charges. And so we say it is a mixture of our covalent bonded and our ionic bonded. Right? So please be careful. Now, how about this? What if we have a CH3, or let's say CH2, Cl2? Would this be covalent, ionic, or is it a mixture of ionic and covalent? Well, take a look. Carbon, hydrogen, and chlorine, these are all nonmetals, right? So these are nonmetals, and so in this case, this would be actually covalent bonded. How about HCO 2Na? So HCO2 sodium. Right? Well, let me write it better because that was terrible. But HCO2Na. Would it be a mixture, or would it be purely ionic or purely covalent? Well, look, sodium is a nonmetal. HCO2, these are nonmetals, right? So let's say it again. Sodium is a metal. HCO2, these are nonmetals. Now, we're actually dealing with a mixture here of covalent and ionic. Why? Because we have a metal, which is sodium, and we have nonmetals, which is HCO2 together. Now, again, this does not contain any charges, and so we say this is actually a mixture. What if I gave you CF4? Would you say it's purely ionic, purely covalent, or is it a mixture? And this is actually purely covalent. Why? Because carbon and fluorine, these are all nonmetals, right? These are all nonmetals. There is no metals in our formula, so therefore we cannot have any ionic bonding going on. Now, what about lithium bromide? Would you consider it a mixture, covalent, or purely ionic? Now, remember what we're going to do again. Lithium is a metal. Bromine is a nonmetal. But again, this is an exception. Remember that these are held together by charges. Right? So these are held together by charges. Lithium having a +1 charge. Bromine having a -1 charge. And so there's actually no bonding, and so we say this is actually purely ionic. So the major differential I want you to take away is that usually for it to be a mixture, there has to be there are no charges. Right? There are no charges, and so these are actually what we call salts, right? So sodium chloride, lithium bromide, potassium chloride, these are salts, and so there's actually not really any bonding. They're purely charges, and even though lithium is a non-metal, you would think that it would be a mixture, but remember again, these are separated by charges, so there's actually not a bond really, but rather they're held together by electrostatic forces, and so we say that these are actually purely ionic.